Hello everyone, this is Steve. Thank you for joining me. Today we're going to graph this fun little rational function here, so let's go ahead and get started. First thing we realize is that there's a number we need to kick out of the domain. If we put a 3 in here, we're going to end up dividing by 0, so our domain with interval notation is going to be every number except for 3. So we jump over 3 like that. In Math 121, factors will never cancel, so we find our vertical asymptotes by just identifying the numbers that we kicked out of the domain. In this case, we just did that, 3. So our vertical asymptote is going to happen at 3, but we do need to remember to write it as an equation of a vertical line, x equals 3. Horizontal asymptote. Horizontal asymptote is found by looking at the degree of the numerator and the degree of the denominator. Now, even though you can't see the powers in this one, both the numerator and the denominator are degree 1, so we have a degree match. If you have a degree match, the way you find your horizontal asymptote is you divide the leading coefficient of the numerator by the leading coefficient of the denominator. In this case, 2 over 1. So y equals 2 over 1, or just y equals 2. All right, X-intercepts. How do we find X-intercepts? To find an X-intercept, you set just the top equal to 0. 2x plus 1 equals 0. Or 2x equals -1, or x equals -1/2. So we do have one x-intercept, and it's -1/2, 0. To find a y-intercept, first of all, make sure that 0 is in your domain. 0 is in my domain because I only kicked out 3. And then you plug in a 0 for every single x. In this case, both the 2x on the top and the x on the bottom are going to cancel out. We're just going to be left with 1 over -3, or -1/3. So our y-intercept is just going to be 0, -1/3. All right, we have our intercepts, we have our asymptotes, we have our domain. We're ready to go to the graph. Please remember that our graphs are not going to be completely flawless. They're not going to show every little detail, but we will get a very good idea of what this rational function's graph looks like. So the first thing I'll do is put in my asymptote. So I have a horizontal asymptote of y equals 2. And I have a vertical asymptote of x equals 3. And I'm very fond of this vertical asymptote because it also tells me how many pieces my graph is going to have. In this case, we're going to have 2 different pieces, one on each side of the vertical asymptote. Do I have any ordered pairs? I sure do. I have an x-intercept at -1/2, 0, right there. And I have a y-intercept at 0, -1/3, right there. Now, our graph needs to hug the asymptotes, and it can never cross the x or y axis where we don't have an x or y intercept. So for the left-hand side, to the left of a vertical asymptote, there's no way the graph is up here like this, because then we miss both our x-intercept and our y-intercept. So it's not up there, it's going to be down below instead. So we go through these 2 points right here, and then we hug our asymptotes like that, and we get half the graph. Over to the right side of the vertical asymptote, the question is, do we draw the graph up here, or do we draw the graph down here? Well, it can't be the lower one, because if it was the lower one, we'd have an illegal x-intercept here. So that's no good, so we got to get rid of that one. Definitely can't be both of them, because it wouldn't be a function then. But we keep this piece up here, and that gives us a sketch of our rational function. So I also graphed this one on a computer just so you can see what a computer did with it. Let's take a look at that. Well, shoot, gang, I'd say we nailed it, because here's a computer-generated image with both the asymptotes, and you can see both parts of the rational function. You can see where the computer has both its x and y-intercept here. Look back at our graph. I'd say we did pretty well. Thanks for watching. I hope that helped.